Yeah, hello, thanks for having us here. From prototype to structure, we are part of the team building houses. And yeah, my name is Johannes Pfau. I'm a managing partner at SSV Architekten in Heidelberg, and I'm pleased to give you a brief introduction to our project, the Wavehouse.
Yeah. And I'm Florian Bienefeld, and I'm the architect in the office who supervised both construction sites.
Yeah, our office consists of a team of 50 architects and planners working mostly on local projects across Heidelberg and the region, ranging from laboratory buildings and educational facilities to housing and museum projects. And over the past years, our focus has shifted towards the refurbishment and transformation of listed cultural heritage buildings. And this context also applies to the Campbell Barracks in Heidelberg. An ensemble of former military buildings from the Second World War, later used by the US Army as NATO headquarters and only recently released for civilian redevelopment. And yeah, there was a small site where we should build a server hotel. One of the last pieces within the large urban transformation was the Wavehouse, a data center building designed to function as the server hotel. The initial form, a simple rectangular box without windows, was quickly defined, but as you can imagine from the image, it was not very satisfying in an architectural way. And after some deliberation, our client showed us a picture from the house in Beckum and said, I want that too. And yeah, we had been working for years with our own in-house 3D printer for architectural models, and we confidently agreed to do that project. The project team assembled very quickly. The client wanted to build on the experiences gained in Beckum, and so Peri and Korte Hoffmann were brought on board, and given the local proximity, it was natural to involve Heidelberg materials for the concrete. The primary aim of the project was to explore and push the limits of large-scale 3D concrete printing. As this was or is, I'm not sure, the largest print in Europe. And the first phase of form finding was carried out using Rhino and Grasshopper, followed by several optimization loops to adapt the geometry and to the printing constraints and technical limits like overhangs, etc. Additional design variants helped define the architectural expression, and on the southern facade we collaborated with the landscape architects to integrate areas of vertical greening, both as solar protection and to visually break up the long wall facing an adjacent kindergarten. The final digital model was then subdivided into print segments and with almost no further processing, sliced and sent directly to the printer. The building had to be divided into 3 print phases because the cobot printer has limitations in length, width and overall height. And in February 23, the first tests were carried out in the fabrication hall while a conventional ground slab was being constructed on the site. In March, the printer was erected and calibrated. And in April, the actual printing began, and we could observe how the first walls rose surprisingly quickly, 1 square meter per hour. And you can see the 2 thin outer printed shells here, held in place by stainless steel wires, approximately every meter of height. The printing had to pause so that the cavity could be filled with in situ concrete, because at that time the material approval did not allow the printed concrete to function as a fully load-bearing wall. But we have progressed since then. By May, the printer was already being reconfigured for the 3rd construction segment, and The segments were separated by gaps into which prefabricated elements were later inserted, elements that had been printed simultaneously during the process. For the integration of columns, the printing path had to be interrupted, and there was this slight over-extrusion that occurs to close the gaps, but this interruption remains visible afterwards. And of course, sharp, perfectly pointed corners cannot yet be produced with this printing method. The vertical print joints and segment transitions are clearly visible in the facade, and for that reason, a surface homogenization treatment was applied later. And small experimental interventions, such as spontaneously printing outdoor seating elements, were valuable on-site experiences for us. To create openings, conventional lintels were still used in this project, but each time the printer had to pause so that a board could be inserted by hand, which again left visible interruptions. Also, penetrations for technical services were likewise introduced manually. The roof slabs are still entirely conventional, as precast slabs currently remain unbeatable in terms of speed and costs. In terms of weather conditions, we learned that the printer offers neither significant advantages nor disadvantages compared to a conventional construction site, except perhaps the workers can take shelter during rain and stay dry. Wind and sun, however, are very challenging. Strong wind or intense solar radiation causes the printed layers to dry too quickly, leading to shrinkage cracks. We had some of them, but fortunately, in our case, these had only visual and not structural implications. After only 170 hours of net printing time, the structure was completed, with an average on-site workforce of just 3 people. Afterwards, regulatory obstacles became a central issue. For example, here you see the installation of fire-rated doors. This was problematic because no approved system existed for integration into 3D printed concrete walls. And so we were forced to remove the printed outer layers down to the cast-in-place concrete core. Similarly, numerous follow-on trades required creative detailing solutions, since the printing process allows only a limited differentiation of construction details. Perhaps the most remarkable aspect of the entire project for us was the extremely high accuracy between the digital planning model and the build result, and all this without the extensive documentation effort typically required in traditional 2D planning. Here you can see the conventional slabs, and then the walls growing in the first part. In the middle, you can see the precast elements to close the gaps. And that's like it works like on the small 3D printer in the office, just bigger.
Okay, I continue. We promised a second project. We learned a lot in the last project. This project is actually in construction. It's called Wavehouse for different reasons. The main idea for this project is also by Korte Hoffmann, and we supported them for the engineering and do at the moment the supervising on the construction side. As you can see, we had difficulty with the lintel in the last project, so we decided to remove all the lintels. We have only windows from bottom to the ceiling, then we have no problem with the roof parrot. We have a wooden roof on top. We optimize the process. I show you in the next pictures. And also this project is the start of make 3D printing and housing scalable. So the project consists out of 3 buildings, but the buildings are only consist of 2 different halves. So we combined in 3 different varieties the halves of the building. So in future we have a large variety and different use cases for that. The printing process is optimized. You can see it here. We have a left and a right side, and the printer prints on the one side of the house, while when he switched to the other side, the companies make the ceiling of the first floor, and when he's done, the printer switches to the second side. So and we separated the balcony from the building because this would be a lot of trouble during the process. So here in the section you can see we printed on the left side, we move to the right side, and then the building grows step by step. Like you can see here on the construction side, one side is always smaller and we print, and the other side there is like normal workers, how we know them from every other construction site. Here we have some details, because that's also a big problem. On the paper it's easy, but on the construction side we have to make the details work. So the first picture is the connection from ceiling to wall, and what's different on this building is that we actually have 3D printed walls that are carrying the ceiling. We also have walls with concrete in it, but that's the first time in Germany that the 3D printed walls are in the our I don't know the English word.
Load bearing.
But they are not ignored from all the others. So, and the second picture is the, as you can see, the reinforced back wall of the elevator. That's the only part of the building for the vertical parts with reinforced concrete. All the other parts are normal concrete. And here you see the anchors that put the 3D printed structure together. But we have to consider the position, because we have to put some steel afterwards in the wall. And if the anchors are too wide, it's not possible. Then you can see our solution for the doors. We did it from the beginning, just from bottom to the roof, and also with direct possibility to the core of the wall. Next thing we want to try is different kinds of corners. We have a smooth corner. It looks smoother and nicer, but it's harder for the furniture at the end. And we have the 90-degree corner. There you can go to some stores and buy your furniture like they already exist, and you don't need some extra solutions. And that's the latest update from the construction site. 2 out of 3 buildings are printed already. The third one will be printed in March 2026, because now it's too cold for the material. So there we have a break in printing, but the rest of the construction site will go on. And at the last page I have some information about the costs, and cost is also a little bit time factor. You can see from the Wavehouse, compared to the new project, we have housing and a lot of more different crafts. But 3D printing, all in all, is 25% of all costs. So when we talk about make a building more affordable via 3D printing, we have only the 25% opportunity. The rest is just normal and has to evolve with the 3D printing technology, and that's it takes a lot of time for this at the moment. And that's the same thing with the time. So when we are fast with printing, or faster than a bricklayer or something like that, it's only the 25% of the building. The rest is just the normal way we did it in the past. Yeah, that's from us. If there are any questions, feel free.
So, thank you very much. Someone from the audience? Or may I? Okay, let's start with Uli.
Thanks for showing, and I saw the building some months ago. So it's one of the bigger ones, and good to see that this develops. And obviously, we all try to see the opportunities for the next steps. And I saw you at the site, and we were talking about all the details and all the bits and pieces. So this is really made. What are your main takeaways? What did you change from the first project to this project? We saw the doors, we saw the structural systems, but what kind of process aspects did you adjust?
I skip one picture back. Yeah, so one of the main factors is the factor time. So we try to make the printer move non-stop. So obviously he didn't move in the night, but every day. So from 8 to 5. Like the workers for the printer. That was one step to reduce the time for the printer on the construction site. Another thing we tried here is to increase the time by increase the layer height. So the first project was 2 centimeter. Now we have 3 centimeter. It's 1/3 faster, obviously. And as you can imagine, if you have some time in the future, you have layers like bricks. It's just like a layer of a brick, and you have to connect them.
Did this pay back financially to get more efficiency in the production?
We are not done yet with the costs because we are not finished. But yeah, it's hard to say because we don't have the detailed cost for the printer itself. The company Perry supports printer, personnel and planning for the printing process. So it's hard to figure out the numbers, the exact numbers.
Okay, oh, there's a hand.
Hi. First of all, thank you for the presentation. It was very nice. I was curious about the straight sections in the walls. I see you have some quite long ones, and I was wondering how you deal with cracking in those sections, because I see you have some. You sort of cover them with tarps. Is this an issue that you have? Because I see the exterior walls have this pattern on them, but in the inside there's some long straight ones. So was this an issue that you encountered, and how did you deal with it?
So in this project, we then I have to go to the first picture. Here you can see it. We decided to make it's a design decision for the first building with the waves. The second one is flat, and the third one will be flat with flaps. So we remove all the material that's over, and we just test what's possible. If it's a design decision, you also can put some some material on the printed wall, but it's easier when there are when there is a little difference, not 1 to 2 centimeter.
But we don't have relevant cracks yet, so
Yes.
maybe in 2 or 3 months we can tell more.
Maybe one question. I'm not sure if it was if they're still filled with concrete, the hollow spaces in the walls, but are there any thoughts for like insulation, or like are you insulating on the outside, on the inside, in the hollow space?
So here you can see it. We have the green is filled with concrete. The yellow is the insulation. And we have on the left side concrete that supports the 3D printed structure. And on the right side, we have 2 columns of steel. They are loose from the ceiling, and they don't have any function unless the 3D printed wall cracks.
The plan is to take them out in 10 years when we can see it stands.
I'd like to pick up on that question with the insulation. When looking at the server hotel, I saw you just filling that like a lost formwork, and there was no insulation at all. And I can imagine in such a server hotel, there's a lot of excess heat. Didn't it make some sense to somehow collect that heat and use it for narrow network heat providing for the neighbors or so? So why don't you insulate the server hotel? So.
Yeah, we thought about that, and as you said, the servers create a lot of heat, and it would be we thought about if we insulate it, we have to cool everything down just to hold the heat. So we decided to not insulate it, but we thought about collecting the heat for the neighbor house, and so there are pipes to install this later, so to use the heat. But in Heidelberg, there's a kind of law. You have to use the local heat they provide. By I don't know the English word for
Fernwärme in
Yes.
German. Yeah, it's
and we also thought about giving our heat to the Fernwärme from Heidelberg, but then we had to put the temperature higher than it is, and this would be inefficient.
But it would have been absolutely logical. So,
because I also see that opportunity to just print in some pipes and to use it as a collector or something, as we see it, for example, with TU Darmstadt's ETA-Fabrik. But yes, thank you. There was another question from you.
Thank you first to show something that's being built in the market around us. I think it's very interesting. I have a question related to the part of the cost that you showed, because the 25% is where you say that we have some sort of flexibility into...
No, it's a potential. So we say we will make cheaper buildings with 3D printing, but 75% of the costs doesn't have something to do with the printing. So we can't save money in those 75% with printing.
Exactly. So my question is, did you do a comparison, for instance, for the building that you're already printing is kind of very close to a conventional building, so it can be prefab in a way. So did you try to do the comparison of how much would it be costly or even cheaper relative to that? And also, if you plan to show the numbers of when you do something more harder to do with a prefab system, like the more curved design that you have, would you also be able to provide numbers of like how much would it cost in terms of if you do it with the traditional way versus 3D printing in that sense?
So the main idea of the project was from Korte Hoffmann, And they also want to prove with this project that they can build 3D printed housing for, I think the number is 2,900 euros per square meter living. But at the end of the project, we have to be honest and compare those numbers. So it's not done yet, so we can't say it, but that's one aim of this project, to prove it or disprove it.
And I think
if you publish the numbers like they had it with the BKI, with the first house from Kurt Hoffmann.
In the project, we agreed. So when the project is done, we will be transparent.
That's good. Yeah.
Yeah, but to lower costs further, I think we have to combine it with other precasted elements in the inner of the house.